This video is about using the trig functions to set up trig ratios and to find missing trig ratios. So remember that there are three trig ratios: sine, cosine, and tangent. And a fun way to remember those is SOHCAHTOA. So remember that sine is your opposite over your hypotenuse, which gives us the SO. Cosine is your adjacent over your hypotenuse, which gives you the CH. And tangent is opposite over adjacent, which gives you the TOA. So we're going to use this idea to set up ratios given a triangle. So number one, we are given a triangle and we're given two angles. So first we're going to start with the reference angle A. So based on angle A, across from my angle is my opposite side. Across from my right angle is my hypotenuse. And my side next to the angle is my adjacent side. So remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So in this case, if I want the sine of A, my opposite side is 15 and my hypotenuse is 17. Cosine of A. So cosine is your adjacent, which is 8, over your hypotenuse, which is 17. And your tangent is opposite, which is 15, over your adjacent, which is 8. Now if we're looking at our reference angle, which is angle C, our opposite side switches, our hypotenuse stays the same, and our adjacent side changes. So notice that the hypotenuse stays in the same spot, but the opposite and adjacent sides switch, which means our cosine and sine of the two different angles are the same ratio. So if I do sine of C, my opposite in this case is 8, my hypotenuse is 17, which notice is the same as your cosine of the other angle. If I do cosine of angle C, my adjacent is 15, my hypotenuse is 17, which notice is the same as your sine of A. My tangent is the reciprocal because my opposite is 8 and my adjacent is 15. So the fraction is just flipping. So let's try another one of these problems where we're missing a side. So because we're missing a side, we're going to do Pythagorean theorem, which is hypotenuse squared equals legs squared plus legs squared. So I have 225 equals 81 plus x squared. Subtract 81, we get 144 equals x squared. So x is 12. Then based on my angle, if this is angle D as my reference angle, when I label my sides, across from angle D is my opposite, across from the right angle is my hypotenuse, and the third side is my adjacent side. So remember that sine is opposite over hypotenuse, so 9 over 15, and we can reduce this fraction to 3/5. My cosine is adjacent over hypotenuse, so 12 over 15, and that reduces to 4/5. My tangent is the opposite over the adjacent, and that reduces to 3/4. Now, if we switch reference angles and we look at angle F, across from angle F is my opposite, across from the 90 is the hypotenuse, the third side is my adjacent because it's next to the angle. So my cosine, my sine of angle F is opposite over hypotenuse, which reduces to 4/5. Okay, if you remember that the sine and cosine switch for the opposite angle, then you could just switch to the fractions right away. If not, then just reset up your fractions like I'm doing. So for cosine of angle F, it's adjacent over hypotenuse, which reduces to 3/5. And my tangent is opposite over adjacent, which reduces to 4/3. Number 3, given a ratio and an angle, determine what trig function is represented. So in this case, we have angle R, and they are giving us 20. which in this case would be the opposite side of R, and 29, which is the opposite side of the right angle, which is my hypotenuse. So we have our opposite side and our hypotenuse, which means this is the sine function. In B, we are given angle A. We're given 21, which is the opposite side, and 20, which is the adjacent side. O over A then is our tangent function. And lastly, we're given angle A, and we're given 20, which is our adjacent side, and 29, which is the hypotenuse, which is our cosine function. Let's try another one with number 4. So number 4, you're given angle N, and 24, which is my adjacent side, 25, which is the hypotenuse. So adjacent over hypotenuse is the cosine function. In B, you're given angle U, and you're given 24, which is the opposite side, and 25, which is the hypotenuse, which is our sine function. And in C, you're given 24, which again is the opposite side, and 7, which is the adjacent side, which is our tangent function. Number 5, given triangle PIG, if the cosine of P is 12 over 37, find the sine of P. So first we're going to draw a triangle. So I have P, it doesn't really matter where I and G go, because we're still just worried about P as our reference angle. Now, they're giving us the cosine of P. Remember, cosine is adjacent over hypotenuse. So if I label my triangle, across from P is the opposite, across from the right angle is the hypotenuse, next to P is the adjacent side. So based on my ratio, I know my adjacent side is 12 and my hypotenuse is 37. I need to find the sine. In order to find the sine, I first need to know what my missing side length is. So I'm going to set up Pythagorean theorem. 37 squared equals legs squared plus legs squared. We get 1,369 equals 144 plus x squared. Subtract 144, and we get 1,225 equals x squared. And then I'm going to take the square root of that, and I find that x equals 35. So my opposite side has a measure of 35. So now I can find the sine of P is equal to my opposite over my hypotenuse, which is 35 over 37, and I can't reduce that at all. Let's try another problem like that. So in number 6, given triangle TUG, if the tangent of G is 3 over 4, find the cosine of G. So first we're going to draw our triangle again. So here's my triangle, here's my right angle. My reference angle is G, and we can put T and U at either point, doesn't matter, either vertex. So I'm going to label my sides. So across from G is the opposite, across from the right angle is the hypotenuse, and next to G is the adjacent side. So remember that tangent is your opposite over your adjacent, which means we know that our opposite side has a length of 3 and our adjacent side has a length of 4. Before I can find the cosine, I again need to know my missing side. So hypotenuse squared equals legs squared plus legs squared. X squared equals 9 plus 16. X squared equals 25. So x is 5. So my hypotenuse is 5 in this case. Then I can find my cosine of G. Remember that cosine is adjacent over hypotenuse. So 4/5. The last big idea we're going to talk about is sine and cosines. Remember earlier we talked about how the sine of one angle is equal to the cosine of the other angle in our right triangle. So anytime I'm giving you sine equals cosine or cosine equals sine, this works because in a triangle, they equal 180 degrees. So if I already have two angles that have to add up to 90, because I already have a right angle, which means that the measure of angle A plus the measure of angle B must always equal 90 degrees if I already have a right angle in my triangle. So in number 6, I have the cosine of 3x equals the sine of 6x. So we're going to add our angles together and set them equal to 90 degrees. So 9x equals 90, x is equal to 10. In number 7, when I add them all together, 5x plus 20 plus 7x minus 2 equals 90. Combine like terms, so I get 12x plus 18 equals 90. 12x equals 72, and when we divide by 12, we get x is 6.